once again, I'm going to go through these examples that were on the bottom of this page, but I need more space because I have ginormous handwriting. So that's what I'm going to do, is I'm going to use more space. So once again, if you have, I'm going to just use the bottom examples. If you have something like log base 32 of 8, well, your first instinct would be writing it like, well, 32 to what power, right? So 32 to what power, so we're going to solve for x, equals 8, right? That makes 0 sense. Good luck with that one. But what is a base that we know that goes into both 8 and 32? 2 and 4 would be my instincts, right? But the issue is we can't do 4 to what power gives me 8, right? That doesn't work. So we're going to have to use 2. 2 to what power gives me 8? That's the same as 2 to the 2 times 2 times 2 is 8, right? 2 to what power gives me 32? 2, 4, 8, 16, 32. So do you see how we're kind of doing this? Do you remember when we had a power to another power? We multiply those exponents, so I'd have 5 times x equals 2 to the third power, right? You can set your exponents equal to each other, and then I would get my answer of 3/5. This is where this idea of changing base comes from. So this rule that we just talked about, which is the change of base, is another method that we're going to use here. So if we have log base 32 of 8, using that rule, remember the bottom number goes on the bottom, the top number, or the big number, goes on the top. And then you had to think about what base would work with both 8 and 32. Well, that would be 2, right? 2 is the only number that would work for both of those. So once you have this written in the proper logarithmic form with this little box filled in, you know what base works for both of these numbers. Remember, you can rewrite this like we did before. So 2 to what power gives me 8 over 2 to what power gives me 32? Well, that would just give me a 3 and a 5, or 3/5. I don't care which method you choose, right? This is using change of base, and this is using exponent properties, right? Whichever one you're more comfortable with, it doesn't matter to me. It's good practice either way. So I would like to try one more of these. So once again, there's this method with the exponent rules, and then there's the change of base, right? 2 different methods. Let's try another example. Let's evaluate. This is the second example on the bottom. So if you have the notes printed, this is just log base 9 of 27. That's the last example on the front page. Which one do you guys like better? Exponential form or change of base? Or do you want to see both? Okay. I heard both, so I'm going to do both. So this time I'm going to start with the change of base. According to our rule, remember this base of 9 needs to go in the basement, so I would have log of 9 in the bottom, and then the 27 goes on top. What number goes into 9 and 27? 3. That's my first instinct, right? And I think this one's going to work, because 3 to what power gives me 27? Well, I think that's 3. Remember, 3 cubed gives me 27. And 3 squared gives me 9. So my answer is going to be 3 over 2. Right? The other way to think about this is, once again, this is asking me 9 to what power? So 9 to what power gives me 27? And I sit there and think, what the heck? I have no idea. So you have to think about what number goes into 9 and 27. Well, 9 is 3 squared, and 27 is 3 cubed. So you're going to get 2x is equal to 3, and then x is equal to 3 halves either way. Does that make sense, though? 2 different methods? Just kind of chill. But anyway, there are special cases where you see something like this, and I'm going to give you an example from your homework possibly to show you as well. But a property where you see log base b of something, and then it has like an exponent here. Oops, I'm frozen. You can't see anything. Sorry, guys. Anyway, log base b of x. Do you see how these don't match, so they won't cancel, right? Boo. Just kidding. All right. So, like I said, these won't cancel because they don't match, right? And we don't know b to what power gives me x to the 5th power. That doesn't make sense, right? But what we can do is take that 5 and move it out front. So this is another property of logarithms that we're going to talk about. So 5 times log base b of x. And this is going to be helpful for questions like number 13. I think it's number 13 on your homework. So you're going to see a question like log base 6 of 36 squared. If you were to actually try to expand out 36 squared, you'd get something in the thousands, and then that would make your problem really confusing. So instead of doing that, we can use this property that we talked about and break down this exponent by bringing that exponent out front. And we can simplify log base 6 of 36 pretty quickly, right? 6 to what power gives me 36? That would be 2, right? And then all I have to do is 2 times 2 gives me 4. So I'd get my answer. There is another way to do this, and if you don't like it, then don't write it down or ignore me, but some of you are going to like this way, so you might want to just pay close attention. So we can start this same question again, right? So if we have log base 6 of 36, you might notice that 6 and 36, like 6 squared gives me 36, right? So let's simplify that. Isn't it 36, 6 squared, right? And then we have a squared on the outside. 2 times 2 is, so using exponent rules, right? Power to another power means I have to multiply those exponents. So I'm going to get log base 6 of 6 to the 4th power. What can we do when these match? They cancel and my answer is 4. Sometimes fancy stuff happens when like these numbers can be simplified to be the same base. If you like it, great. If you don't, stick with the cool fancy thing of bringing that exponent out front, right? Okay.